Hi everyone, welcome back to our machine learning session. In this session, I will show you how to practically implement support vector machine on top of our diabetes project. In the previous sessions already we implemented KNN, random forest, decision tree, and this is also one type of supervised learning algorithm. And this support vector machine we can apply for both classification and regression. Since our diabetes project is a classification problem, we are going to apply support vector classifier. Regarding theoretical concepts of how a support vector machine will work, that already I discussed in the separate sessions. You can go through my support vector machine theoretical concepts. In this session, we'll discuss how practically we can implement support vector classifier. Open Jupyter Notebook. First, import the corresponding package, support vector machine. In support vector machine, we can apply it for classification and regression. So we need to import corresponding classifier package. So see here from sklearn dot support vector machine import support vector classifier. Since we are applying for classification problem, you need to import corresponding classifier package. So execute it. And for all the remaining steps are same. So data pre-processing, like first you need to read your CSV file into the pandas data frame, and then divide the data into input values separately, means separate input and output features. So input into X variable and output into Y variable, and then divide the data into test set that may be based on your client requirement or manager requirement or team lead specifications. You can change this ratio, that is 70-30 or 80-20 or 85-15 or even 60-40 based on your requirement. You can change this ratio. Once after dividing train test split, all the steps are same. Like first you need to create an object and then divide, fit your model and test your model. So see here, so create a separate cell. Here it is, I will make the heading as support vector machine, support vector machine implementation, implementation. So support vector machine implementation here, what is the package for support vector implementation? That is SVC. SVC. Create an object. So name with corresponding variables, support vector machine model, SVC model. And this object you need to use to fit your data. So the function which is used to train is .fit method. You need to pass the corresponding train values for the input and output. So during training, we are going to pass both inputs and outputs. Change the variable to SVC model. And so during testing, we are going to use only inputs. SVC model dot predict, which is used to predict your test values and which will give the predictions. These predictions are compared with actual test values to see how much accurately your SVM model is predicting. Execute it. And you can see still there is an improvement in your model. If you see previous models, and this naive is given 74 accuracy and random forest it gave some 71, and then so decision tree given 68 and so on. If you see our support vector classifier, it gave around 76. Still we can improve the accuracy of our support vector classification or naive Bayes or other decision tree or random forest by parameter tuning and pre-processing our data set. In this session, just we applied all the default parameters for support vector classifier, but we can tune our model based on there are different parameters exist in support vector classifier that we can tune to get the better accurate. That's all for today's session.